Hello and welcome. In this video, we're going to take a look at the ASUS ProArt PX13 for 2024, featuring the AMD Zen 5 processor and the Radeon 890M graphics, as well as a RTX 4050 inside to give it basically an all-around workability and usability. So this is the little laptop that can do it all. I've done a full review of this laptop. Please go check that out. I'll drop a link here. And of course, in this video, what we're going to do is take a look at the thermal performance and the fan noise performance of this laptop in the various different modes in the ASUS ProArt Creator Hub software. I've also reviewed this software in earlier videos on my channel in ASUS Pro level laptops. Go check out the ProArt P16 review I did just a short while ago. That one will cover the ProArt Creator Hub if you're interested in the control software and have questions about what it has to offer in particular. So first of all, the way we're going to test this is we'll go through all of the different modes here, excluding the Windows mode. We'll start with whisper mode, standard mode, performance mode, and then finally we'll take a look at manual mode and tuning the different fan profiles as well. We'll also give you the heat level on each different operating mode on the laptop, as well as we'll talk about what the fan noise is. We'll give you readings, decibel readings from our sound meter, and we'll also talk about we'll use our temperature gun here to take a look at the overall surface temperatures of the laptop. So let's jump in here. Initially, we've been running in whisper mode now to kickstart this video, and we'll swap over here to Furmark. So this has been running for about 30 minutes now. And we can see here that, we're getting about 21 FPS. It's running on the 4050 GPU. There's 4 exhaust vents, 2 on the sides here and 2 along the back of this device. Has liquid metal on the CPU. Pretty typical for most ASUS laptops for 2022, 2023, and 2024. Of course, it says here it's got 2 fans inside. This one does not have a vapor chamber for cooling. Now, I've pushed this laptop further back to imitate when your hands are on the laptop deck, where you would be sitting roughly, and it's about 1.5 feet is the average distance. So we're taking these readings at roughly about the same distance here to show you 40 to 41 decibels in this room here with just the laptop's fans running. Now, mind you, despite whatever the meter is saying, the sound is actually pretty silent. I hear a very faint buzzing of the sounds. I know that they're still spinning, but it's pretty much quiet in whisper mode. All right, now let's take some temperature readings here. So first, looking at temperatures around the WAS keys, we've got here 40 degrees Celsius and about 44 is roughly maximum. There is some little hot spot in there. Because the way that these laptops are designed, most of the components are pushed towards the back. We have exhaust on the left and right, and of course on the rear of this device as well. It won't be really hot around the keyboard area. In fact, it does get hotter around the hinge area, and because the way that the exhausts are positioned, some hot air is exhausted up towards the display, particularly in laptop mode. So let's take a reading here up towards the top to show you how hot it starts to get. We're getting about 50 degrees Celsius on the unibody near the actual metal hinge of this device towards the screen. And if we look, the maximum here is about 56 degrees Celsius, so that tells a very different tale. But nonetheless, you should never need to put your hands there in normal operation. Now we'll swap over to our next mode here. We'll go into standard mode using the ProArt Creator Hub. At this level, the fans are certainly audible. I can hear them. 44 decibels is fairly acceptable for a standard mode operation. And keep in mind that you can actually do a lot of your workloads in standard mode as well as gaming. You'll get enough power pushed to both components, the CPU plus the GPU here, that even in standard mode, without doing anything to this laptop or ever even opening the ProArt Creator Hub software, you can still game on this laptop in that mode. Let's take some temperature readings again across the WAS keys and then towards the upper hinge of the laptop. Okay, so temperatures have climbed a little bit, so we're looking at about 40.5 degrees Celsius on the WAS keys and roughly 42.3 maximum across the WAS keys area. And now in standard mode, we'll take a reading across the hinge. So certainly a different story there. So as we approach the top of the hinge there's most areas which are around 42.7 degrees Celsius, so about 2 degrees hotter. All right, next we'll swap here into performance mode. This is the highest mode that's built in by ASUS and calibrated for this laptop. So let's swap over to performance mode. So certainly a lot more noise here, but still typical and in line with most gaming laptops. We're seeing about 48 decibels from this device. Next, we'll take some temperature readings across the WAS keys and of course across the hinge. Alright, so very similar story to what we saw in standard mode. There isn't actually quite that much difference. 41 degrees Celsius and 43.7 seems to be the max there. So nothing too uncomfortable. Pretty typical, I would say, for most gaming laptops. And now let's take a reading across the hinge here, running in performance mode. And indeed, as expected, it is quite hot up there towards the hinge of this laptop. 45 degrees typical, but a maximum of 55.1 degrees Celsius. For the final mode, we're going to swap over to our ProArt Creator Hub. We're going to select manual mode here. I'll talk about the specifics that I'm going to use there for testing on this device, and then we'll take some readings, both thermals and of course audible as well. So to select manual mode, you have to go here, toggle manual mode, click the little edit button, and you'll see the CPU and GPU tabs here. So we've maxed out the CPU sliders, and the fan curve here will max out the fan curve as well. So basically with the golden curve here, it will ramp up immediately and stay at 100% fan speeds for the CPU. And similarly for the GPU, we're not going to apply a offset in terms of an overclock for the base clock or the memory clock of the GPU. We'll leave those there. Thermal target is a maximum 87 degrees for the RTX 4050, 85 watts of typical GPU power, and 10 watts of dynamic boost. And of course here again, we'll crank these fans up to 100% almost immediately, and save and apply. Again, pretty typical for what you would hear from gaming laptops in the manual mode with fans cranked up to max at 7500 and 7800 RPM. And let's take some temperature readings beginning with the WAS keys. So WAS key area, it is cooler now actually, despite what you would have expected. Despite pushing all that power, those fans when ramped up to full speed can definitely cool this device. 33 degrees Celsius around the WAS keys and 39.1 degrees maximum. And a temperature reading in manual mode across the hinge and the front of this device here, the top of the keyboard deck, to see what kind of maximum temperatures we've got there from the heat. And again, despite what we saw in performance mode, it's a little bit cooler here actually running in manual mode, and that's of course because we've cranked the fans all the way up. It is certainly a balancing act between noise, thermal temperatures, and how much power is being pushed to those devices. So it is not unexpected here. 43 degrees Celsius typically and 52.8 degrees maximum. Next we'll talk about internal temperatures and power levels to both the CPU and the GPU. So we'll turn our on-screen display on here. First we'll show you in FurMark, and then we'll show you running an actual game workload to show you what the temps look in each particular mode. Running in Whisper mode here, we can see that we're getting about 70 degrees on the CPU package with about 10 watts roughly to that CPU, and about 70 degrees on that 4050 GPU here, roughly pushing about 30 watts. Alright, and running in standard mode here, we see temperatures of 80 degrees on the CPU and roughly still about 10 to 11 watts on that CPU package. 85 degrees on that GPU now at about 65 watts roughly speaking. And in performance mode, we're getting about 6.5 watts still. It's a little bit lower, still well below 10 watts on that CPU package for 78 degrees Celsius. And on the GPU power now, we're hitting right up that against that thermal throttle limit of 86 degrees Celsius. We can see here as it pops up to 87, it pulls the GPU power back down. So we're getting this toggling of 74, 75-ish watts, roughly down to 60 or somewhere below 70 watts. And finally in manual mode here, after running for a couple of minutes, we're still getting 10 watts of so of power roughly to that CPU, 75 degrees. Because the fans have ramped up a lot now in manual mode, it is running a little bit cooler on the CPU package. GPU is still trying to push as much as it can towards that thermal junction limit. So we're getting 81 to 86, 87, 88 degrees bounce back, throttle back, push back up again, throttle back, push back up. We're seeing here roughly somewhere between 80 to 90 watts now on that RTX 4050, which is pretty close to full maximum capacity that's possible in this laptop, plus that extra dynamic boost, perhaps 5 watts or so roughly speaking. Alright, here we are in Dragon Age's the Veilguard. So now we're using our RTX 4050 GPU there. We're running in the high preset here graphics with DLSS turned on and upscaling mode set to quality. We're getting roughly about 50, high 50s, somewhere close to 60 FPS in this game. Running at 1900 by 1200p resolution here. I think it's a pretty good show. And this is running in Whisper mode on this laptop using the ProArt Creator Hub. That means we're getting roughly about 30. You can see there on the screen, the GPU has only about 30 watts of power. So the RTX 4050 is very impressive. I've been saying that all throughout last year and repeating the same thing this year. For those of you who just want to have a nice laptop that can get some gaming done, a 4050 should not be discounted. Of course, 4060 gives you a little bit more oomph for those games because of that extra VRAM. But this here is definitely very sufficient for a nice gaming experience here. So now we can see here we're getting about 55 to 60 watts. Roughly, I believe 60 watts is the actual. We can see here the 78 FPS now running in high performance or high preset at about 50, roughly 50 to 60 watts of GPU power on this. So we can see here that even if we get into a very, very heavy battle scene, we're going to get some slight frame dips or frame rate dips, but it's not going to drop from 75 FPS to 30 FPS. So you'll have plenty of breathing room there in high preset to still stay close to or above 60, even in very, very heavy and active scenes on the game here. And we see here immediately that there is more audible fan noise now because the fans have been cranked up, of course, to deal with the extra heat because we're pushing more power now to both the CPU and the GPU, and immediately we see our CPU temperatures here jump to 94 degrees because we're pushing nearly 40 watts, 35 to 40 watts of power to that Zen 5 CPU, and the GPU is holding steady at 85 degrees, pretty much against this thermal junction limit, but we've got the GPU power now being reduced because more power is being pushed to the CPU. But you can see here our frame rate isn't really impacted. We're still getting roughly the same FPS in this game, despite the power level on the mode having changed. Pop into manual mode here. So CPU mode, I've boosted up to 70 and 80 watts for power boosts and 65 watts sustained. And GPU, I've left overclocks alone, but I have maxed out the base power for the GPU at 85 watts and 10 watts of dynamic boost. And then we've got fan curves cranked all the way up here, and we can see immediately that there's quite a lot more noise because the fans have really wrapped up nearly to 8,000 RPM now. And we can see still roughly about the same power figures, about 40 watts to that GPU still, and about 50 watts, 55 watts now to that CPU, not really helping in getting this any more frame rates because despite however much power we push to the CPU, this is very much a GPU bound game. So it's not going to give us any more performance in this game. It's a similar story in other games. I don't need to demonstrate lots of other games here to prove my point, but I think everybody gets what is happening here. So that'll be it for now.